without actually division, prove that this particular expression is divisible by this particular expression. So it's quite simple, right? What is that we have to do? We have to make use of, yes, factor theorem. But there is a issue. Factor theorem, it does not work for quadratic equation as a divisor. It's always linear equation. That's why I made this x plus a or x minus a and so on and so forth, ax plus b. This is the general expression. I'll change this actually later on. I need to change that. Not very happy. Anyways, point is they are linear equations, not quadratic. So we can't add your factor or remainder theorem over there. So what is the solution? See, any point of time you get any kind of such question. It can be quadratic or cubic or anything. If similar question comes, all you have to do is you need to factorize x square, whatever the denominator is, and then make use of the factor theorem. Let me show that. So let d of x, the divisor, be equal to d of x, and we have p of x, the dividend is 2 to the power of, not 2, sorry. Okay, x square minus x plus 2. Agree? Now, so we need to prove what? We need to prove that d of x is a factor of p of x. So I'll go with the hint, whatever they're given. So I don't know exactly what to do exactly, It's a new variation. I mean, obviously variation is new. So it's a variation. So I have to just go with the flow. So they're asking us to factorize d of x. So let's do that. How do you factorize something? Either formula method or splitting the middle term, right? So here we'll use formula method. Sorry, splitting the middle term method. When multiplied, I should get 2. When added, I should get 3. So what is the number? So you know the method. Write the factors of 2, that is 1 and 2. Obviously, this has to be minus 2 minus 1. Simple and straightforward. So d of x is equal to 1x square minus 2x minus 1x plus 2. Right? And then a bit more splitting the middle term and all of that. Common. What is common over here? X is common. So we have x minus 2. And here minus 1 is common. X minus 2. And again we have x minus 2 common. So we have x minus 2 into x minus 1. Agree? Okay, so we have done what they have given. We had to factorize, we did. Where is it going though? I mean, how can I go about doing this and proving all of this? See, the point is this. We have a linear equation wherein, since we have linear equation, we can make use of remainder and factor theorem now. We'll just make use of that. So what we are looking at is two set of linear equation. Set of linear equation, not two set. Set of linear equation. So we'll go back to our concept of, yes, let u of x be equal to x minus 2. We'll take it as a question which is starting just now. X minus 1. We have to prove that these two are factors of p of x. Let's do that. I'll explain the logic behind this. So first we'll start off with 0 of u of x. Okay, we'll figure that out. So let t be the 0. So u of x when equated to t will give me an output of 0. That is t minus 2 is equal to 0. So t is equal to 2. Okay. The next step is 0 of v of x, not t. V of x. So here to let t be the 0. And we have v of x when equated to t will be equal to 0. So t minus 1 is equal to 0. So t is equal to 1. Now, to prove that they are factors, what we have to do? Just substitute in p of x. So p of x when equated to 2, let's see what happens. So we have 2 into 2 to the power of 4. Okay. I have the equation written on a sheet of paper. So I'm looking at that. That's 2 into 2 square minus 2 plus 2. Right, guys? So we have this is 2, 4, 8, 16, 32. So clearly 32 minus 5 into 8, that is 40. 248, yeah. Plus this is 248, plus 2 minus 2 gets cancelled. And this clearly all of them will cancel and you have an output of 0. Good. So we just proved 1. And p of x when equated to 1, let's see what happens. 2 into 1 to the power of 4 minus 5 into 1 cube plus 2 into 1 square minus 1 plus 2. Okay, so we have 2 minus 5 plus 2 minus 1 plus 2. So 2 is 6, 5 and 1 is 6. So your output is 0. Minus 6 and plus 6 is 0, right? So what can you tell? So as per factor theorem, you can clearly tell that u of x and v of x is a factor of p of x. Okay. And additionally, we can tell this as u of x and v of x are the simplest form. It's directly telling that they are in this prime factor form kind of thing. Simplest form, the product u of x into v of x can divide with a remainder 0 or is also a factor of p of x. Hence proved. The last statement is the very new thing. That's the variation. So let me explain the logic first. See, all we did was, okay, let us go through the steps. First we split the term and all of that. We found the linear equation of the given divisor. Then we found the zeros, and as per the factor theorem, we proved that these two are factors of p of x. Very simple. Additionally, we are doing this. We are multiplying that and telling that is also a factor. How is this? See, for example, 189. If I want to divide by 21, obviously I though can't tell if it's actually divisible by 21. So what will I do is I'll write 21 in its prime factor form, 3 into 7. Is 7 a factor of 189? 189, is it divisible by 7? Yes. Is 189 divisible by 3? Obviously it's, if you know the divisibility criteria for 3, it clearly is. So since 7 and 3 can divide 189, right? So 21 also will be able to divide 189. Again, it has to be in its prime factor form. I can't just take some random 400 or say 600. Then I can't tell that since 600 is part of 3 and 3 can divide this, so 600 also can. No, it's not that. Okay, so there is a certain logic to this, right? Please understand that it's in its prime factor form. So now let me explain this particular set of things with that example. See, this is like 21 and this is like 189, and this is nothing but finding out that it has 7 and 3 as it prime factor. In the simplest form, it's this. Agree? Okay, and now with all of this from here till here, we just proved that 7 and 3 can divide, right, 189. Since 7 and 3 can divide 189, the product of 7 and 3, that is 21, can also divide 189. That's all we did. Okay guys, and now your answer. You can copy this, and also we'll be doing it on the graph. So now you guys can copy this first. Okay, let's see the graph now. So I already typed in the expressions. You can pause and check if that is right. So the first one is of 4th power, the second one is of square, quadratic. How will the graph look? What do you think will happen? Just think about it. It's fun. Okay, you have your thought organized. Let's see. Now can you figure out? Let me, before I zoom in. Okay, let me explain now. This red is your divisor, a quadratic equation, so you have a smiley face. Dividend is all thoda wiggly and stuff. The fun part is this. It's not only at a single point, but 2 different points is where the graph will meet. So clearly at 1 and 2, the graphs are meeting along the x-axis. Can you see that? and so this 2, right, can, not those two, but yeah, this quadratic equation can divide this fourth power equation. You got it? Can you see that? 1 and 2 itself, those are your zeros, and that's what we found 1 and 2 are to be their zeros. Can you see that how things match and stuff, right? I hope you guys try all of this. It's fun. I mean, I don't know how else to put it. It's fun for me though. Okay, so yeah, you guys copied this now. I'll finish the video.